Hello everyone. In this video, we'll show you how to quickly edit and decimate and visualize large point cloud data in PointKit. First, let's make sure that our document units match our data and that we have adaptive rendering and GPU accelerated selection. You can also choose to lower your render quality for a smoother experience. So I'll load up this 5.8 gigabyte E57 file. And I'll move to center and make sure that my import units match my data. I won't worry about the other options. And because this is such a large data set, I'll skip ahead to when the data is fully loaded, as it'll take a minute or two. Now that our data is loaded, I'll switch to flat color mode so we can see our vertex colors. And the first thing we might want to do is clean up some of the floating points. We can use our selection tools for this. Great. Now that we've cleaned that up, we might want to decimate our data. You can also choose to decimate before cleaning up the floating points. Let's decimate so that we have 1 point every 2 centimeters. For working with large point cloud data, make sure that voxel downsampling is turned on for a faster experience. You could also choose random decimation instead of even spacing. Now we're down to 17.5 million points instead of just over 400. The next thing we might want to do is only deal with a portion of our data. If we still want to keep the rest of the vertices in the model, what we can do is select and copy to new mesh. I can then delete that selection from the original mesh, and I've now transferred it over into a new entity so that it's toggleable separate from the rest of the data. You can do this as many times as you need. And now that that's done, you can save the data to whatever file format you want. I'll choose to export as a PBN so that it's faster to load into Extract3D 2. Now let's load up some LAS data instead of E57 data. With LAS data, you get optional geospatial input class filtering, so you can deselect classes that you don't want to import. Or you can load the same data multiple times and select different classes to separate them into multiple meshes. For example, I could choose to just load the buildings here. If you're doing this, make sure that you're not moving to center, as the recentering is applied after your geospatial class filtering, and so you might end up with different transformations. We'll recenter as a group later, such that we can still move our data to the center. And I'll also flip my Y and Z axis to match the coordinate system of PointKit and SolidWorks. Now let's do the same thing, but instead of loading the buildings, let's load up the vegetation. And last but not least, let's load up the ground data. A shader is automatically applied based on whether or not your data has normals and color information. If a point cloud has points and colors but no normals, then you'll see a flat shader is automatically applied regardless of the selection up here. You can, of course, change this later. If a point cloud has no colors or normals, then the height map shader is automatically applied to that data, so you can still visualize it effectively. Now that we've loaded up this data separately, we can choose to toggle the individual classes and see only the data that we're looking for. Here's when we would decimate or clean up our data if we need. Now, because it's geolocated data, our data is quite far from the origin, so a transformation matrix is automatically applied. We can recenter our data by going to Edit, Transform, and Recenter by Group. Now, by turning on our ground plane, we see that our data is now properly centered. The centering is performed in X, Y, and Z, so if I needed to adjust the height, then I could enable my translate options and bring my meshes up. And to apply that transformation to the data, we can go to Edit, Transform, and Rebase. Now, when we go to our height map is now based on the ground plane. Now, an important thing to note is that the height map is on a per mesh basis. So you'll notice that I have some areas here that are much higher red than the green areas of the buildings above. However, if I were to group these entities, then you'll see that the scaling is done on all of the data.